What's going on, guys? Mr. Jones coming at you once again. Today we're going to learn about task 4.2. It's a solidified task. What that means is that you're going to use your knowledge from the last task of piecewise functions and linear equations and extend it and solve these problems. So let's go ahead and get right into it. We're going to talk about the things that you should notice and here in a second. Michelle and Rashid love going on long bike rides. Every Saturday, they have a particular route they bike together that takes 4 hours. Below is a piecewise function that estimates the distance they travel for each hours of their bike ride. Okay, so right off the bat, I'm thinking of, dang, I want to know what the graph looks like. And even though we might not have to draw a graph, we can kind of draw a sketch. So time is generally your x-axis, and this time we know it's in hours. And since they only travel 4 hours, that's the biggest x value I put on my entire graph. What are they doing over hours? They're traveling a certain distance, right? Distance. Let me go ahead and try and write this sideways here. Distance. Pretty good, huh? All right, so distance, and it's distance in miles maybe? We're just going to put distance. Let's just put miles. Distance in miles. Okay, so since we do know that, and we have these 4 equations, okay, these are the equations. This is the domain over here, right? Domain. So this equation right here only happens from 0 to 1. This one happens from 1 to 2, from 2 to 3, and from 3 to 4. So we have 3 different equations, and every hour they're changing the constant speed that they're riding on their bike. I just want to point something out. Normally we see y minus y1 equals m times x minus x1. If you add y1 to both sides, you now get y equals m times x minus x1 plus y1. Okay, so that's the type, that's the form right here, the second form that they're putting it in. So for example, 1/16. Okay, 1/16 is the point here. Okay, that's my x1, y1 there. 2, 26, and 3, 40, right? So we're going to go 10, 20, 30, 40. Okay, so 40, 30, 20, 10. Now let's go ahead and just plot these points, and then we'll try and graph it to the best of our ability just to kind of get an idea of what's going on. Although you don't really have to do all this, you should be able to answer these questions. Okay. So in fact, I'll let you guys go ahead and plot that. Pause it, plot it if you want. I'm going to plot it here in a little bit. But let's go ahead and move forward and start thinking about the questions. Okay. So all we know a point of these lines, we know the slope of the lines, and we know the domain of the lines. So question number 1. What part of the bike ride are they going the fastest? And what part are they going the slowest, right? So number 1, think about that. What would it mean for a line for them to be going faster? How should the line look different? If they're going faster, they're covering more distance in less amount of time. It would mean their line's going to be steepest, and slower would be less steep, right? This line right here, they'd be traveling at a slower speed than this one. So that's how you can answer question 1. Think about what part of the equation is going to tell you that, right? What part of the equation? All right, number 2, what is the domain of this function? The entire function, what is the domain? You have these 4 domains. How could you combine them, right? How could you combine them? All right, find f of 2, right? See, we don't actually need the graph for this. Find f of 2. Okay, f of 2, what does that mean? Remember, it means you're going to plug in 2 for all the x's. But in the equation, what does x stand for? Hours. So it's asking, explain what this means in terms of the context. Okay, what does it mean in terms of the context? If I say what's going on whenever x equals 2, what are you solving for? What do you want to know at f equals 2? Go ahead and solve that. How far have they traveled at 3 hours? Okay, how would that be different than this? Would that be the same thing? How far have they traveled in 3 hours? Is that the same thing as saying f of 3? Okay, so go ahead and answer that question. And then what's the total distance they traveled on this bike ride? That's what you want to know, is how far total did they travel on this bike ride? In other words, I think that means what's your y value going to be at the very end, right? What's the y value at the very, very end whenever we're at 4 hours? Okay, next question. Sketch a graph of the bike ride as a function of the distance traveled over time. So now this is actually where they want you to sketch, if you can sketch. And it's just saying to sketch the graph. So we talked about that earlier. Let's go ahead and get those points in. Maybe you paused it and did it already, but if you got those points, then we should be able to get it here pretty quick. So let's check it out. All right. First one I'm going to plot is 116. So 20 is there. That means 15. That's probably about 16. So 116. Okay, they obviously started at 0, 0. No time, no distance. And then we have a straight line like that. The next point is at 226. We already talked about that. So 2, there's 25. So maybe like around right there or so. Okay, and now the line looks like that. And notice my first line is steeper because the slope was 16. This next slope is only 10. All right, I guess I should have made these lines different colors. I guess we could do that now. Let's try our best. All right, so stop there, start there, and that should have stayed green. All right, my next point, I'll make this in purple. This next point is 340. So the 40 is way up here. And then the 3 is way the heck up here. And now we have a line that goes like that. And then all right, I'm going to have to start that over. So let's try that again. Obviously just made a mistake because I started graphing. I forgot about the 16x. Right, I forgot about the 16x. Okay, what point do we have at the 16x? All right, so let's go ahead and graph this really quick. The 16x, we have a point at 0, 0. We have a point of 0, 0. And then we have the point 116 that we talked about earlier, right? 116. So about 116 there. Go ahead and make that line. Then my next line, and we'll pretend that it's connected, right? My next line is going to go to 226. So about 226 goes about like that. Notice that slope is not as steep as the purple slope because the purple slope has a slope of 16. This one's only 10, right? Next point at 340, so way up here at 340. And then lastly, whenever we get to the 4, all we know is the slope was 12. So if you went up 12 over 1, so if that's 40, this must be 50. So we're going to be up here somewhere, and then boom. Now we have our last one. We'll make that one in red. All right, and the graph looks something like that. Yours probably looks a little bit prettier because you have graph paper, hopefully. Just make sure that your scale on the left is the same distance for all the 10s, the same distance for all the 1s, okay? All right, moving on. It says Rashid also has a route he likes to do on his own and has the following continuous piecewise function to represent the average distance he travels in minutes this time, okay? So this is time in minutes now. So the domain from 0 to 20 and 20 to 50, that's minutes. And then these are the equations. Okay, so this right here, guys, is very, very similar from 1 through 6, but it's this new problem. So question 7, what's the domain? What does the function tell us? You should be able to answer these questions on your own. Number 8, what's the average rate of change during the interval 20 to 50? What's the average rate of change? So in other words, between 20 and 50, what's the slope of that line? Okay, that's what it's really asking on number 8. Number 9, over which time interval is the greatest average rate of change? In other words, over which time interval has the biggest slope? Okay, so which fraction is going to make it go up the fastest? And then find g of 30, g of 64, g of 10. Whenever it says this means, it means in the context of the problem. So earlier, whenever it asked us to do f of 2, that meant at 2 hours, he was a certain distance away. He was 26 miles away or whatever it was, okay? And then we're going to go down, complete the last equation by finding values for A and B. So the last equation, you have to figure out what those values are. And then number 12, sketch a graph of the bike ride as a function. So just like we did here, you're going to sketch your own graph and then do it one more time for this next piece. By the way, on this problem where it asks you to find A and B, how could you find A and B? How could you find A and B? Well, I'll tell you what, look at this previous problem over here and look what your last ones are, right? So wherever your domain starts, that's probably the point they're choosing, right? That's probably the point they're choosing. Then you have to use your slope to figure out what the other value is at that point, okay? So think about what your x1, y1 would be, where it would have to connect. It might help you a little bit to draw the graph first and see what comes out of it, all right? And then last but not least, you're gonna go ahead and finish up the task here. It's very, very similar. It just tells you no story anymore. It just tells you difference traveled in kilometers. And so it's same thing, time, and then distance in kilometers. And then it wants you to find the C value here. Once again, where do they connect? So if you're at the point 10, use this slope to figure out how high you have to go up. And then we can go over it in class 2, just remind me. And we'll talk about it and go over this one so I don't forget. All right, and then what's the domain? What's the range? You can skip number 16. We haven't been talking about it, but remind me, and we should talk about it. Which 5-minute interval of time has the greatest slope? That's really the question on number 17. And then a little bit more function notation. So h of 8, h of 15, you should know just to plug in for x there, and you should be good to go. All right, guys, a little bit longer task, but I think you have the skills to do it. So go ahead and get to work, and please let me know if you have any questions. I know this is some new stuff, and we're not in class. I don't actually know what you need help with. So let me know what you need help with so I can help you. Have a good one, guys.